Okay. Hello students. Today we will discuss on IRODOV question number 1.8. So according to question number 1.8, question number 1.8, two boats A and B moves away from where anchored at the middle of a river along the mutually perpendicular straight lines. The boat A along the river and the boat B across the river, having moved off an equal distance from the weir, the boat returned. Find the ratio of time of motion of boats tau A by tau B if the velocity of each boat with respect to water is eta equals to 1.2 times greater than the stream velocity. Means according to question number 1.8. According to question number 1.8, suppose this is a river and from midpoint boat A is moving in this way. Suppose from O to A the distance is D, and another boat, second boat B, is moving from O to B. This is also equals to distance D. Means boat A is moving in this way. The velocity of both boat is equal according to given question. Means the velocity of first boat is V1. Means let the velocity of both A and B is V1 and V2. Therefore time taken by the boat A moving from point O to A and return to point O. Return to point O is given by tau A. Means time taken by the boat A moving from point O to A and return back to point O. Therefore we know that time is equals to distance upon velocity. When boat is moving from point O to A, then the velocity of boat is along the direction of flow of stream velocity. Then its equivalent velocity is time is equal to distance is D upon V1 plus V2, because boat is moving in the same direction of stream velocity. Therefore its equivalent velocity is V1 plus V2. And when boat is moving from A to O, then boat is moving upstream, means just opposite to the flow velocity. Then its equivalent velocity or final velocity of boat is V1 minus V2. Means when boat is moving from O to A, then its velocity is V1 plus V2, and when it is moving from this way, then it is V1 minus V2. This is the time. Hence time taken by the boat A moving from point O to A and return back to point O again is D upon V1 plus V2 plus D by V1 minus V2. After solving we get 2 V1D upon V1 square minus v2 square. This is time taken by the boat A moving from O to A and return back to point O according to given situation. v1 square minus v2 square, equation number 1. And next, for boat B, according to the situation of boat B, if boat is actually, according to question, boat is moving from point O to B across the river. For moving O to B, it must be moving like this. Even means at any angle theta to just opposite to the stream flow, stream velocity. Suppose this is equals to theta, then along OAOB its velocity is v1 cos theta, and opposite to stream velocity is v1 sin theta. So according to situation, if boat is moving across O to B, across the river means O to B, then v1 sin theta must be equal to the stream velocity. Means we can say v1 sin theta equals to the v2. Therefore sin theta is equals to v2 by v1, and time taken by boat B, moving from O to B and return back to same point O is given by tau B is equals to distance upon velocity. Velocity is v1 cos theta, and for moving B to O, it's also equals to d by v1 cos theta. After solving, we get 2d upon v1 cos theta. So from this equation, sin theta is equals to v2 by v1. Therefore cos theta is equals to root over 1 minus sin square theta is equals to 1 minus v2 square upon v1 square. Means finally v1 square minus v2 square upon v1. Putting the value of cos theta from this equation, we get tau B is equals to 2d upon v1 into root over v1 square minus v2 square upon v1. So v1 cancel, and we get 2d by root over v1 square minus v2 square. So according to question tells us find the ratio of time taken by the boat A moving from O to A and return back to same point, and same as for B, tau A by tau B. Find the ratio of time. Means tau A by tau B is equals to 2v1d upon v1 square minus v2 square into root over v1 square minus v2 square upon 2d. 2d cancel, and we get v1 upon root over v1 square minus v2 square. Means tau A upon tau B. According to question, the ratio of the ratio of V1 upon V2 means equals to eta is equals to 1.2. Hence we can say, if we just take V2 as a common factor, then V1 upon, this is V2 and this is V1 square upon V2 square minus 1. If V1 upon V2 is equals to eta, therefore V1 square upon V2 square is equals to eta square is equals to 1.44. Then V1 upon V2 is we get 1.2 upon root over 1.44 minus 1 is equals to 1.2 upon root over 0.44. After solving we get tau A upon tau B is equals to 1.8. This is required answer for this question. According to this question, two boats are moving perpendicular to each other. One is along the direction of stream velocity and another is across the river. So according to first situation, time taken by first boat is d by time is equals to distance upon velocity, equivalent velocity plus distance upon that situation. We get this is equation number 1. And for second boat we get 2d by v1 square minus v2 square root के अंदर. Therefore according to question, tau A by tau B is equals to the value of tau A and the value of tau B. After solving we get v1 upon root over v1 square minus v2 square. Putting the value of given situation, we get tau A by tau B equals to 1.8. This is the required solution of question 1.8. Thank you.